I am Ilmari Heikkinen. I'm here to talk to you about WebGL. So I work for Google UK as a developer programs engineer. I give talks, do slideshows, write demo applications, documentation, articles, all kinds of things. I'm on Google+, on Twitter, and I have a blog that I update infrequently. So today we're going to be talking about WebGL, a really quick overview of WebGL, nothing overly techy, and then I'm going to show a small tutorial into using the GJS JavaScript 3D library. So WebGL is a Kronos group standard. JavaScript meets the GPU. It gets you fast programmable drawing. Okay, I'm Finnish. I have difficulties with these English words. So OpenGL. So basically, it's the mobile OpenGL version. OpenGL ES 2.0 for the HTML5 canvas, and the OpenGL ES 2.0 is the graphics library running on most modern mobile phones. So iPhone 4, it's running that, and that's how it gets great graphics. And now we have that in the web. So the basic thing that you do with WebGL is you have a bunch of shaders, and you draw using them. Now, if that says nothing, then it's basically a way to do either 2D graphics or 3D graphics, but in a very generic fashion. So you just have these little programs that you do stuff with. So the basic idea is that you have a list of points, you send them over to WebGL, and the vertex shader is a small program running on the graphics processor. It puts the points onto the screen. And then you have another small program running on the graphics processor going through each of the pixels in this triangle that you created. And basically, it just computes the color for that. So you've got vertex shader, you've got fragment shader, and then you've got the list of points, and that's WebGL in a nutshell. Yeah. So it's just a fast way of putting triangles, lines, or points on the screen. And what you actually do with them is up to the programmer. So it's a very low-level API, requires quite a bit of code to get anything complex going. But the difference between shaders and shaders is that this is a very simple shader. It's just creating a cube, and you've got a rotation, and it's coloring it black. So simple stuff. Now, if you do a more complex shader, this is the same program code on the JavaScript side. It just has different shaders. So it's got the wavy shader in the vertex shader, and then it's got this spinning gradient thing in the fragment shader to create the nice color thingy. So browser support for WebGL is Chrome, Firefox, Safari. It takes a little bit of mangling. Opera 12 and onward support it. Chrome Frame supports it. For Internet Explorer, there is IE WebGL, which is a plugin to put IE WebGL into IE. And then there's this little JavaScript library called CWebGL that's actually trying to implement the entire WebGL drawing library in JavaScript. It's interesting. It probably doesn't run very fast, but it might be useful for static images and like. So, uses, games, image filters, visualization, 3D applications. If you want to do video with nice filters on it, you could use WebGL to do it really fast. And basically anything that you could use some fast drawing for. I think I've got some demos here somewhere. Here. this is probably one of the most popular WebGL applications at the moment. Yes, it's Angry Birds. Angry Birds has a accelerated, the high definition version is using WebGL for drawing, and that's why it runs smoothly, even in a large window on the browser. I've got 2 stars on this level. I don't know how I can get 3 stars, but I am going to try. Okay, maybe not that way. I need to aim a little bit lower. Ah. Yes. This is my presentation. I'm going to be playing Angry Birds for the next 40 minutes. Come on. No. I don't even have sounds on, so you can't hear the pigs laughing. Okay, another application is Tinkercad, this web-based CAD application for doing, like, I think it's for modeling stuff that you could print on a 3D printer. So what you do is you do drawing on the client side, and then it sends your drawing to the server side, and the server computes some magical CAD application geometry stuff to create this nice look. I think I can actually rotate this around somehow. No? Or maybe it's a second key. Yeah. Okay, so yeah, so this is just a very nice application of 3D rendering in the browser. Then we have another game. This is a 3D game, Gun Bros, ported over from an iOS title. So this is just pretty simple, nice game 3D graphics running in the browser very smoothly. And I don't get this game really. So I am going to go and return to the presentation. So libraries. Let's write some WebGL. So, and we are going to use a library for that because WebGL as it is verbose. I'm going to talk about the 3JS library. 3JS is a lightweight, easy-to-use JavaScript 3D engine. It's an open source project by Mr. Doob. It's on GitHub. It's got a bunch of useful features, including the WebGL renderer, but it also has a canvas renderer and SVG renderer if you want to do something that's not super complex, nice-looking 3D, but you just want something simple. You could use the 2D canvas renderer, which is more compatible. So the basic setup is that you create a WebGL renderer. Here, tell we want an anti-aliased renderer and set its size. Put it in the document and clear it. And what we get is something very exciting. Yes, a blank screen. And it has this color on it. Very sexy. So, no. Okay. It's not the end of the presentation, okay? So, next I'm going to actually try and draw something. So I'm going to create a camera, set the field of view, the aspect ratio, and the near and far planes for the camera. It's pretty jargony, the 3D cameras. Then create a new scene, add a new cube to that. A cube is I'm creating a mesh with the cube geometry and setting the material for the cube. Then I just add it to the scene and render the scene from the camera on the renderer. What we should get is a black cube in the middle of the screen. Yeah. Well, it could be better. It's not very exciting yet. So let's animate it. So the basic process is that we do something, we draw a different image on every frame, and that gives us animation. So here we have this little animate function that sets the position of the camera on there's some trigonometry. What this basically does is moves the camera based on the current time in a circle around the cube. And then we just render the scene from each of from the new camera viewpoints, and tell the browser that yes, I would like when you need to draw a new frame, then please call the animate function, and I will update the canvas. Request animation frame, by the way, is really nice. So we get a camera rotating around the cube. Well, it's still a little black. But so yeah, lighting. Let's do something about the blackness. Okay, create a light. Put the light somewhere. Add it to the scene. Then we create a new cube that's going to be lit by the light. And for the lighting, we need to use mesh Lambert material or mesh Phong material, which are using a shader that actually responds to the light. Then we put it on top of the black cube and add it to the scene. And the result is this. It's lit on one side. There's one light, one lit cube, one black cube. It's not very complex. So let's do something more complex. Shadows. So 3JS has newly gained support for shadow maps, which lets you do shadows. They're pretty finicky, but if you work with them a little bit, you can get some nice results out of them. Basically the way to use them is to go to the renderer, enable them, then for each of the lights, make it cast shadows, and each of the objects that should cast or receive shadows, set cast shadow or receive shadow to true. So now at the beginning we don't have anything much interesting with the two cubes. So I'm going to add a ground plane for getting the shadows. So again, create a new geometry, create a new material, a new mesh using the geometry and the material. And put it on the screen, flat under the cubes, make it receive shadows and add it to the scene. And then I'm going to make the cube spin, just more trigonometry. This is just spinning the cube in a sort of an elliptical orbit and making it spin at the same time. And it looks pretty neat. I also have some mouse interaction so I can move the camera around, look at the scene from different angles. Oh, and I made the black cube red and lit. So that was the magic bit. Okay, so basically lighting, set mesh material to Lambert material or a Phong material, create a new light, add the light to the scene, and turn on shadows if you need them. Not much work, but looks nice. So maybe you could do something more useful than a flat plane and some rotating cubes with 3D. I like cubes, but they're not, everyone's cup of tea. So actually, I'm going to just create more cubes. Okay, so what I'm going to do here is a bar graph. So I have here a regular 2D array, an array of arrays. Then I create a new object, and that's going to be our parent object for the bar graph. Add it to the scene, then go through all the elements in the bar graph and create a new cube with the height set to the value at this grid position. So this should create a nice little bar graph out of the grid values and put it in a different position on the bar graph object and make it cast and receive shadows. And I also did some extra magic, like colors for this. But this is a nice bar graph. and you can spin it around, look behind it. Hello, I could add little cars here. That would be pretty nice. So again, this is about one slide of code, and you can get a nice bar graph going. Then if you have some more dimensional data, like maybe you have particles or 3D points that you would like to visualize somehow, and you don't really know, okay, how to do that, we are going to create a particle system. So here's the particle system, and it has a point geometry and the material. The material is just a basic material. We're going to use the vertex colors in the geometry to set the color of the particle and create 10,000 points at random positions, put them in the geometry object, and put a different color for each object, each of the points based on the position of the points, and then add it to the scene and put some fog in there to make it to make the depth more visual. So the result of this one slide of code is this. Oh, actually, I cheated. I added the lines for the grid and the titles. But anyway, so you can rotate this around. 10,000 points. Looks nice. Looks complex. There is some structure to it, so it's not just totally random. And I also thought that, well, maybe I could animate this one as well. And so I did, with JavaScript. And this is JavaScript animating 10,000 points in real time. And yes, we can still go around and look around. So again, this is very little code, pretty nice effect. Okay, what kind of a shape did we get out of that? It's an S. I think this is an S. Okay. So next, well, it would be nice to have some controls. But writing controls, writing UI widgets, I don't really like it. Usually I was always writing my own widgets, and that's very painful. But now I tried to use dat.gui, a nice little library from some of the Google Data Arts team guys in San Francisco. So you just say, okay, I want to control the scale of the cube, the X scale. You set the minimum, maximum step, add sliders to the GUI like this, and this is 4 lines of code, and what you get is this little box here. So what I can do with this is change the size of the cube interactively. This is pretty nice for 4 lines of code. And yeah, you can rotate this around and whatever. So that's just too easy, I think. So what I want to do is write a little system, maybe a little 3D editor. So I'm going to need a current object that I'm going to be editing. So I create a proxy object, and when I'm editing the proxy object, I'm going to pass the edit to the proxy object to the currently selected object. So this is basically it. It just sets the current object and sets the current values to the current object position. And when I'm editing the X value, it's going to edit the current object's position also. And to select objects, I copy-pasted this bit of code from one of the examples. For the example is doing like rotating cubes, and then you can click on them to add points to them. But I made it, so I took that and grabbed the code to find the objects that are under the mouse cursor. And this is basically all it does. It's about 6 lines, copy-paste it. That's probably the easiest way to do it. So if you're interested in what it does internally, it projects a ray from the mouse pointer position to the scene and finds all the objects that intersect with that ray and returns them in the order that they are hit. So here we go. This is pretty much the same thing as the previous one, except now I can move the cube around. Oh, no, no, no. OK, let's take the width high, depth high, create a new cube, move the new cube a little down, create another cube. Let's take this one, actually, and move it around a little bit. There we go. Make it high and thin. So this kind of a simple 3D modeler, it's maybe 50 lines of code on top of the basic rendering code. So it's not very complex. And you get pretty nice results out of that. So cubes again, cubes, cubes, cubes. Let's do something else than cubes. There's a collada loader. Collada is a 3D exchange file format that you can save your models in collada format, and then there is a collada loader for 3JS that lets you load them into your scene. So I'm loading here a monster model and putting it into the scene. It's not too complicated. And there was actually some code in the example that makes this model animate. So this is what we get with those 10 lines of code or so. A walking monster. It doesn't have shadows. That was too hard. So, okay, I think that is the end of the talk about. So 3JS is an open source project on GitHub, a JavaScript library for doing 3D graphics. It's pretty easy to use. It's fairly efficient. Got a bunch of nice features, and you can use that GUI for doing simple GUIs. And WebGL is nice for 3D graphics on the web. Thank you. The slides are not online yet, but I will get them online just as soon as I'm out of here. OK, questions?
Is the relation between WebGL and OpenGL, is it a subset of the functionality, or is it a completely different thing?
WebGL is sort of, it's pretty much the same API as OpenGL ES 2.0. And OpenGL ES 2.0 is if you take the desktop OpenGL and you throw everything useful away, or rather everything helpful away, so that all you have left is shaders. So it's a bit of a parallel thing. The extensions are somewhat the same. Yep.
I have a question regarding the hardware acceleration. If it's going to work in the future on mobile phones, do you think that it's going to drain the battery?
Yes, I believe so. I mean, it's going to hit the graphics processor, and the more, well, basically the more processors you've got running, the more power it's going to take.
Do you think it's going to be like more demanding than native apps?
More demanding than native apps. It's I think that if you run GL code on the graphics processor and do your drawing with that, it's going to be faster than if you would do it on just on the CPU. And since it's faster, it's going to keep the processor occupied for less time, which takes less power. Yep.
Are there any major drawbacks to using the 3JS library? Anything that you simply can't do without writing native WebGL? I mean, going to low-level WebGL.
Low-level WebGL. it doesn't have a complete feature set. So sometimes you do have to drop down to native WebGL and just.
Can you, for example, plug in your own shaders easily?
Yeah. It's. I had 3 slides about that, but they were sort of like, okay, here you have a shader, here you have another shader. They look really complex, and here you have a slide on how to plug in the shaders to the object, and this is what you get, which is the spinning, colorful thingy. So yeah, you can use your own shaders. Yeah. Sorry, what was that? Security of WebGL. Okay, so the security of WebGL, the working group is working on that. We've got driver bugs. When we encounter driver bugs, we blacklist the driver. And if we have a driver bug that's going to, or if we have some sort of a spec flaw, then we try to plug the spec flaw, like what happened with external images. So now the images have to be same origin policy. And with shaders, there is work going on the WebGL robustness extension on making the shaders less liable to hang your system. So it's pretty much the same thing as with Windows 7. If it takes a long time to run some graphics thingy, then just reboot the driver.